let's start with sets. So starting with set. Set is unordered. Unlike tuples and lists, set is unordered. So unordered means you cannot use indexes. And it's mutable. So unlike tuples, we can change, insert, or remove elements from a set. And unlike list and tuples, you cannot add duplicate elements. So set, even if you add one, and again if you put in another one, it wouldn't take that one, and it can only have the number one once in a set. And I've written it for you. You can't access individual elements of a set by its index because it doesn't have a fixed order. So let's take an example for this, and set is defined in curly braces. So let's start with an example. So let's take set1. This is a function. Set1 is equal to set. This is used to create an empty set. So as it's written here, this keyword, this function is used to create an empty set. Or you can even make a set using set of, in a list, 1, 2, 3, 4, 5. And let's print set1. Okay, let's make the set 2. And let's see what an empty set looks like. An empty set when printed looks like this. Even if you give the print function, it gives you the same result because this is an empty set. Coming to set 1, let's add another 5 here. And when we run this line again, we see the other 5 is not added because set cannot have repeating digits. And if you mention repeating digits, it takes it away and you only see a single digit. So this is clearly useful when you have a tuple and you want to remove the duplicate digits. Just convert it to a set and convert it back to a tuple. Next, coming to add. So since set2, let's even check the type. Set2, it's a set. Since set2 is empty, let's add some things into it. Set2 dot add 1. Set2 dot add 2. And set2 dot add 1. So if you add again, it doesn't give you an error, but in the set, it's just a single element. Coming on to remove. So since add is for adding to a set, remove helps you remove the element from the set. So we remove 1 here, and set only has a single element. So what if you remove something that isn't there? 5. It gives you an error because 5 doesn't exist in the set. You're trying to remove this. And this remove keyword needs one argument or it will give you an error. So mention the one or the element you want to remove in these parentheses. Coming to discard. Discard removes a specific element from the set if it exists. So if you type .discard 2 and you type set2, it's an empty set. But what would be the difference between remove and discard? If I call the same thing again and I mention another element and print set2, even though 6 is not available in set 2, it doesn't give you the error, but remove gives you the error. So that's the difference between remove and discard. these are two different cases, so use them accordingly. So let's see what the pop function can do right now. So let's create a new set this time, which is set3, and it contains elements 1, 2, 3, 4, and 5, and 6. So now what do? Let's pop out an element. Before popping out, let's assign it a variable so we can take it. Set3.pop. So typing S, instead of popping from the last or the sixth one, let's see it in the case of a list. List 1 is 1, 2, 3, 4, 5, and 6. List 1 dot pop. It pops 6. But in the case of set, it popped from here. We call the pop function again and print S. This time S is 2. It has popped this one. And obviously, checking set3 shows 3, 4, 5, 6. And in list 1, can we pop 3? Yes, list 1 has popped 4 because this is indexing, so third index is 4. But in the case of set, if I give something here, 3 exists here, and if I give this, it gives you an error. So instead, the pop function doesn't take an argument, while in the list, it can take an argument. So it pops this one, and in list, it pops from the back, while in set, it's popping from here. Coming on to clear, we have seen this in list also. So let's clear the set3 dot clear. And set3 is an empty set because this set has been cleared. And coming to in and not in. In is used to check for inclusion of an element in a set, while not in is used to check for exclusion. So is 3 in set3? Why not? Because it's an empty set. So is 5 not in set 3? It's true because an empty set doesn't contain 5. So not in returns true. Moving on to the len function. Len function gives you the length of the set. So len of set 3 gives you 0. And if I add something into it, set3 dot add 1. Now length of set 3 will be 1 because it has a single element. Coming to copy, we have seen this copy before also in list. So what does copy do? It gives you a copy. So let's revise the basics once more between assigning the equal to sign and the copy function. So let's make a new set. Set4, okay, let's give it a small name. Let's give it my set this time. My set is set of 1, 2, 3. So A is equal to my set. Print A, you get this. A dot add 10. And now I print A. It has 1, 2, 3, and 10. I print my set. It also has 1, 2, 3, and 10. That is because it's given an equals to sign, an equivalent sign. So this, any changes to A leads to changes to my set. And even if we do changes to my set, it leads to changes in A. So what you need to do in order to avoid this is just to give B is equal to my set dot copy and B dot add 111. This is B, but my set remains as it is. So that must be noted. Coming to set comprehension. This is also an important thing. So let's deal with it after learning the for loops and if conditions, because we'll learn it with the list comprehensions we have kept aside for. So after the list comprehension, we'll also take in the set comprehension. So union. You might have seen something called the union before. Going on to the whiteboard, let's see what an union is. So if there is a set A which contains 1, 2, and 3, there is a set B which has 4, 5, 6. So A union B. This refers to union. This is union symbol. What it does is it takes all the elements from here, and combines it to a single set. So 1, 2, 3, 4, 5, 6. So what if there's a 1 here? In union, this one remains as it is. So it's only a single one because set can't have repeating digits. So how do we implement union in our program? So let's take set 1 is equal to set of 1, 2, 3. Set 2 is equal to set of 4, 5, 6. And then for union, we use, there is no use symbol, but for union, we use dot union function. So let's take a new set. This will become our union set. So set 1 dot union of. Here we'll have the second set. Print set 3 and voila, we have the union set. So what if it had a 4 here? Union will still be 1, 2, 3, 4, 5, 6. There is also another way of using this instead of union. So instead of writing this, you can just write print of set 1, and there is something called a straight slash set 2. You can find it in your keyboard, and it prints them in union, or just assign set 3 as set 1 union set 2 and print set 3 here. That's how you get union. Let's go on to the next one. Next one is intersection. So what does intersection mean? Intersection here will refer to something as common. So if A has 1, 2, 3, B has 3, 4, 5. So A intersection B, this is the intersection symbol, will give us 3 because the common element is 3. Let's see how we program it. So if you give set 1 dot intersection of set 2, you get 4. Why did we get 4? because this is our set 1 and set 2. Remember, I added a 4 before, so what's common between set 1 and set 2 is this 4. You can even assign it a variable and print it out, or like this thing in here, we can just type set 1 and symbol set 2. So we are using this and symbol right here, and there we have it. Coming on to difference. So difference is a little tricky, so let's check onto it with board example. So when we give a set called 1, 2, 3, and 3, 4, 5. So when we give difference, it's not going to give us 1, 2, 4, 5. This is wrong. So what difference instead gives us, if this is the set and if this set is being used to find the difference, it's going to check each of these elements. If this element is present in this set, it removes that element. If this element is present in this set, it will remove it, and all the elements present in this set will be removed, and this set will be shown. So the result would be 1, comma, let me write it again. It will be 1, comma, 2. So let's see how it's done. Yep. Set 1 dot difference of set 2. It gives you 1, 2, 3. Here it checks if 4 is there, 4 is available, so 4 is removed. 5 and 6 don't exist, so it gives you 1, 2, and 3. Or instead, you can also assign it a variable or even print this directly if you want. And this can be written as set 1 minus set 2. So this is the set in which comes here, and this is the set which comes here. That must be noted, because if I give set 1 minus set 2, it's going to remove from this set based on this. And coming to symmetric difference, this one is the one that is rightfully opposite to this. So it returns a new set with elements in either set but not in both. So that is where it will show you this answer right here. It will give you 1, 2, 4, 5. Because the 3 is there in both of the sets. I think it's messy, but it's fine, right? It's a work of art. So yes, I guess so. Don't be angry. This and this 3 is common. So what's not common? This, they change the color. This and this is not common. So let's implement it. Set 1 dot symmetric underscore difference of set 2. Remember, there is an underscore here, so don't forget it. Remove it, it will show you an error. So here it has removed 4, because 4 is the common element. So if you want to remove duplicate and get non-duplicate value, so it's not going to repeat them, but it will remove the duplicated value and 4 won't be seen here. Or what we can do is, as part of our shortcut methods, instead of minus here, we will use something called an exponential sign. It gives you the answer. 1, 2, 3, 5, 6. Going on to issubset. What is issubset do? It checks if it's a subset. So this will mostly give you a true or false value. Let's check it out. So set1 dot is a subset of set2. False. Why false? What is a subset, you may ask me? So let's see what a subset is. So a subset means if there is a big set called 1, 2, 3, 4, 5, and we take two of them, two, this right here is a subset of this big set because all the elements of this set is there in this big set. So if it is 1 comma 6, it's not a subset because 6 doesn't exist in this. Even an empty set is a subset of this set. Any set, empty subset, if there's a set called 1 with just one element, its subset will be the set itself and also this empty set. So every set has an empty set as its subset automatically. And this right here, since it is 1, 2, and this, all the elements of this set is a part of the big set, these two are subsets. Subset symbol would be this. So let us take something called new set and let's give it 1, 1 comma 2, and let's check if set 3 is subset. Instead of giving is subset, you can use this short form called less than or equal to set 1. It's true because set 1 has 1, 2, 3, and 4, and this set 3 has 1 and 2. But if I just give 6 here, I'll show you false. Same example I took here. This 1, 2, 1, 6. Moving on, we have superset. Superset is the damn opposite of subset. So what does superset do? Superset checks if that set is superset of the set. So it checks if this set has all the elements of this set instead. Let's write it somewhere else. So let's see this set and this set. So it checks if this set is superset of this set. So it's the direct opposite. So here let's take our set 1 and set 3. Is set 1 the superset of set 3? No, it's not because it's 6. So it cannot contain 6. So let's just prove it to you. Set 1 dot is superset of set 3. Okay, wait, I followed the 1. It's false. But what if set 3 was set of 1 and 2? You get it true. And so, what if we give something like this? Will you get true? Obviously, it's not. Because set 3 is a subset, not a superset. So, like subset is less than or equal to, set 1 will be greater than or equal to set 3. So there you have it. It's a Boolean value which is returned. So you can even assign it a variable, but the value of A will be Boolean. This is similar to assigning A as A is equal to true. So it assigns true to A. This Boolean value is useful while we deal with the if loop, so we'll see it there. Now let's see disjoint. So this also gives you a Boolean value, either true or false. So if we compare two sets, let's take two sets here, A and B, 1, 2, 3. If this set has any element similar to this, if this is 3, it's going to give you false. But if this is 13, it will give you true. This set B shouldn't have any element of A. Let's see it in practice. So it would be, let's take a set A, or shall we consider our before examples? Set 1, set 3. Are they disjoint? No, because 1 and 2 is 1 and 2. So set 3 dot is this joint of set 1 false. But if I change this to 7 and 8, they are disjoint because elements are not similar. Okay, so now let's take another example to check if your base is strong. What if I give you something like an empty set? What do you think would be the answer here? Will it be true or false? It's going to be true. Why? Because an empty set doesn't share any elements with the disjoint set, or this set right here as 1, 2, 3, 4, but this empty set is not sharing any of the elements. So comparing this with this will give you true. Coming on to the frozen set, like a tuple, it creates an immutable set. So we use the frozen set function here. Let's take a variable name. This can be anything you would like to have. It may set 9 or even ABC is equal to frozen set of, let's give it an empty set. Now ABC is a frozen set. Even the type will be a frozen set. So if you do ABC dot add 10, it gives you an error because it's immutable. And even printing a frozen set will give you this. Let's add some elements into it. So we can see that it will show you the frozen set with the elements inside here. So it always gives you this. Even if you print it, it's going to give you this. So this set is frozen as it is. So if you want to remove this, the only way you have is to convert it back to normal set. So use the set function and ABC this way. And this set, if assigned to a variable, can be used with the other functions right here. So 10 has been added. So that's about the frozen set. Coming on to update. We have also dealt with update before. So what update does is it updates the set which is given before it. So we can give set 1. These are the elements. So let's take another set 2. So set 1 dot update with, you can either mention your elements in here, or let's just give here set 2. Set 1 has been modified with 4 and 5 here. 5 is already existing, so 4 has been added. So it's like a union, so it has updated the set. Similar to union, but in union, we assign s is equal to set1 union set2. So this doesn't modify set1, but this modified our set1. In the same way, we can do it for the rest, which we will see here. And these will be the last three topics in sets. And let's move on to the next one. So coming to difference update. What is difference update? So we saw what is difference. So difference update updates the original set. So taking set1 dot difference underscore update with set2. This is similar to set1 minus set2, but what is it does is it's going to put the output back into set1. And printing set1, we have the difference. So set2 has 4, 5, 6, and this is set1. So 4, 5, 6 is removed, and you have 1, 2, 3, and 10. So set1 has been changed. Coming on to intersection, which is the common elements. Now, as you can see, set1 and set2 don't have common elements. So what do you think will happen to set1? Intersection update, since there are no common elements, it will become empty. So it is an empty set, right? And symmetric difference, as we have talked, it's the direct opposite. So when these three got removed at first from 4, 5, 6, these were removed. Instead, it's going to remove these and it will print you the extras. So the common ones will be gone and the uncommon ones will be in the set. So let's see with another set. Set1 will be of 4, 5, 6, 7, 78, 9, fine. So set1 dot, if you give set2 dot symmetric underscore difference underscore update with set1, print set2. 4, 5, 6 is gone, and what's uncommon in these two? It's 7, 9, and 78. This is symmetric difference update. So note that there are 2 underscores given. And with that, we are done with set. And let's go on to floating point numbers. These are decimal numbers, and we will show how we can represent or print floating point numbers in this lesson. You can use 3 ways: using this percentage symbol, using dot format, and string. We have learned these two. We'll also learn it with this and how to use floating point representation for all 3 of them. Right. Starting with the first one, which is percentage. Let's print it. So the floating point number is a percentage sign. Let's give 1.2f. And here outside the quotes, we give percentage, some numbers with a bunch of numbers, and print it. We get this. So what is the significance of this? This number 2, which is after the decimal point and before the f, refers to the number of digits that must be included from here. So if I give here 6, you can see these 6 numbers are added right here. But why is it 63785? 50 because this 49 is rounded up 50. And if I give here 7, which is odd number, you get it as it is. 848495. But if it's an even number, it must be noted that there is something called rounding off the last digit. And what must be the significance of this number? Shall I give it 2? There's no difference. If I don't even use it, there's no difference. So what is the significance? Let's go 10. There is no difference. Because what is the length? The length of it should be a string. So this is 14. So this much has a space of 14. So this right here refers to how much spacing is given for this thing. So if I go above it, above 14, it's going to add a space. So if I go 25, there is this total would amount to 25. That's what this thing does right here. So that is how you use floating point numbers with the percentage symbol. Now, let's see how it's done with the dot format. So I'm pretty sure that we have done the dot formatting for with arguments and quarks, with args and quarks. So let's see how it happens in floating point numbers. So the floating number is, here we have our curly braces again, dot format of bunch of numbers with points, and in the curly braces we have a colon with dot to f. This looks similar to this. So I can even add 23. That's the same thing, but you only have this much, and this, if I change it to 6, there are 6 digits. And by the way, you don't want any digits and you just want the number. My bad. Just give dot 0f. But in this case, you can just give point f. In this case, you can't give point f, give dot 0f. This gives you this. But what if this number right here is 9? You can see the number is rounded off to the nearest decimal point. So 5.9, this can be rounded to 6. So hence it's 1, 2, 3, 4, 6. Now you might want to even add something else in here, like, and I am this. So since this isn't named some or something, just put human in here. You get, and I'm human. But if this is an identity or a named parameter, this will give you an error. Why? Because this needs to be a quark, and you get I am human. So that's how you use floating point numbers also. But can you give it something like s is equal to this? No, that's not possible. Why? Because this adding quotation marks here makes it a string, not a floating point number. So it must be noted. And what if I want multiple? That is also possible with just a space and 1f. But you also need another set parameters. So right here is this one, and right here is this one. So that is how you do it. But what if I give this thing, this identity, this named parameter at the first. Do you think it will work? No. Why? Because it's mostly, and it should be that arguments or the unnamed parameters should come first, and it should come only the named parameters can come at the end. So make sure the floating point numbers are given preference and written at the first. Even if you put this thing right here, it will give you an error. Want me to do it? Let's just confirm it. See, it gives you an error. Positional arguments follow keyword arguments. This is also same with argumentative. So if it's something like this, for example, and this one, you need to make sure that this thing is written here. I, comma. See, I comes here. Let's just give I. But if I put this in here, for example, a given error. I. So make sure you follow this order in which, but the thing is, if this is right in here and this is here, you can place this thing at the middle. So make sure you follow this notation. So according to the position, the values must be assigned. So that's all about using dot format. Let's see how it's used in strings, shall we? Strings, it's so damn similar to this, but instead of writing it here, we write it directly here. So print the floating number is, we need the string first. Floating number is, open and close braces, and here we can give the semicolon with dot to f. But before that, we have to specify the numbers here, like this. So now it is 2, 3, 4, 5. My bad. What is it? Okay. So it's 2, 3, 4, 5, 6 dot 3, 4, 2. Because it's dot 3f, you can even give your numbers in here, like 25, and there you go, your spacing is. So now coming to another part, there is something called filler values. So instead of these blank spaces right here, you can just add a 0 instead. So what you do is you put a 0 at the start, and you can see it's all filled with zeros. So what it does is it only works for a 0. Any other number, this will only give you 125 spaces, and without the 0, it's just a space. And the same thing can be done in here. You put a 0 here, it's going to be filled with the filler values. And the rest of the numbers are the same. So if you give 23, the length will be 23. And that's it for floating point numbers.